Okay, so this is going to be a extra example for the bearings problems. You are going to need a calculator to do this. You can't see me with my calculator, obviously. So I'll kind of verbally talk out loud when I'm using my calculator, but you're going to have to try to figure that out on your own. So I kind of have to make these up on the fly. There's not very many of them. So let's try a ship sails on the ocean breeze due east from a port at, I don't know, 100 miles per hour for 3 hours. It then turns. This means 17 degrees east from north. And keeps going. Find the distance from the ship to the port and the bearings after 6 hours of travel. So these problems are a tad tricky and require a little bit of drawing. So let's see if we can do it together. I'm always going to just draw what it gives me first. So it's set. I'm going to start over here. This is port. The ship starts by sailing 2 hours east, or I'm sorry, 3 hours east. 3 hours at 100 miles per hour, which is the not as nice way of saying 300 miles, because 3 hours for at 100 is 300 miles. This is where it gets a little tricky. This is where you have to understand what that N17E means. So the first thing you have to do is you have to draw your north-south line. So bloop, bloop, bloop. This is my north-south line. It says I went 17 degrees from north, and I went in the east direction. So that means that in the east direction, because east is to the right, I went 17 degrees from north. So I know that's a little tricky. So what I did was I drew the north-south line. I then kind of estimated, or I sketched 17 degrees towards east from north. That's what this little fancy thing means. 17 degrees east from north. Whew. My ship is now here. Ship. And I want to find, not only do I want to find the distance from here to here, but I want to find the bearings. So I'll start by label this as D. Not only do I want to find this, but I also want to find the bearings. And the bearings are always from that north-south line. So I'm going to sketch that again. And I'm actually looking for this right here because it's the degrees between the north-south line and my direction I'm traveling. However, I will tell you, or I'll give you a hint, that you will need this. It doesn't matter what, I'm going to label it alpha. You're going to need it to find theta, but you can use whatever letter you want because I know some of you don't like the letter alpha. Now, if you look at this, we don't really have a right triangle yet. However, we can make one. Don't worry. However, if we do make one, we have no idea what this length is, or this length. But we do need those later to find both alpha and our distance. So now that I set up the drawing, this drawing is going to be eerily similar to the one you're going to see on an assessment. I'm just going to change the thing that's moving and the numbers. So let's start with all these things I'm missing. Right now, I have theta, alpha, the distance, A, and B. I don't have enough information to find D. I don't have enough information to find alpha. I don't have enough information to find theta. So you're like, what the heck do I do? Well, the first thing I notice is that this angle is whatever 90 minus 17 is, which is 73 degrees. So now I have this little fancy right triangle over here that I can use to find some trig relationships. If you look at the problem, oh gosh, I don't have enough room here, but I'm going to try to fit it. It says I'm traveling for 6 hours. So I traveled 3 hours this way and 3 hours this way. So this is also 3 hours at 100 miles an hour, or 300 miles. So to find A, I actually know that the cosine of A, the cosine of 73 degrees is A over 300. So A is going to be 300 cosine 73, or approximately 87.71 miles. Okay, next I'm going to find B. Sine of 73 is B over 300. And B is going to be 300 sine of 73 to approximately get 300 times sine of 73. Make sure your calculator's in degree mode for this problem too, because 286.89, which I didn't double check, so let me do that right now. Yep, make sure it's in degree mode because this problem's in degrees. So again, that first thing that I did, maybe it'll help if I make this a little bigger, because I'm going to be looking at it a lot. Whoa, did not want all of that garbage. Make this bigger. And don't touch my, no, it didn't take everything. Okay, never mind, too much work. I'm zooming in. So right now I solved for all the little pieces over here because I made a right triangle. I used sine and cosine relationships to do so. I now have enough information to solve for D. So now I'm going to ignore the little right triangle and find the large right triangle. So this is why this problem gets a little confusing, because you have to find a lot of little pieces first. Oops, miles. So if I look, the distance squared is going to be that 300 plus A squared, which is 87.71, plus B squared, because it's a right triangle, so I'm using Pythagorean theorem. I'm going to just quickly click some numbers on my calculator and solve for D. So at 300 plus 87.71 squared plus 286.89 squared. Oh no, excuse me. You did not even listen to me, calculator. 387.71 squared. Okay, take the square root of that to get d, and I get d is equal to, or approximately equal to, 482.31 miles, which is perfect. I also have enough information to find alpha. I'm going to use that number again. I can actually use, never mind, I'm going to use b and d. So the sine of alpha is b, which is 286.89 over d, which is 482.31. To get alpha, we have to use some inverse trig. Alpha is equal to the inverse of that stuff up here, of that stuff. I don't feel like writing it, even though this probably takes just as long. Yeah. Oh, except for I'm missing part of the 8. Yeah, that didn't actually work. Which gets me approximately, so again, I go second sine, which is sine of 286.89 divided by 482.31 to get 36.5 degrees. Now that's alpha. Theta is going to be 90 minus 36.5 degrees. So 90 minus second answer is going to be 53.5 degrees. I could have done that without a calculator, but it is 8:30 at night, and I'm still at school, so I'm a little tired. So, how do I combine this and this into the final answer? So, the ship is 482 miles from port I'm just gonna write at it is 53.5 degrees east, because we're going towards east, of north. So 53.5 degrees east of north. And that is my final answer. So how would you practice that? There's one on the multiple choice pre-calc honors review that's phrased just like this. I'm going to phrase the one on your test just like this. So again, just as I verbally walk you through the steps, I set up my right triangle. It's actually built of two littler triangles. I had to find all of the parts of the little right triangle first so that I could find the parts of the big right triangle. From there, I solved for the distance and alpha and found theta. Some key things you have to remember is that when we talk about bearings, we're always talking about the degree between the north-south line and our direction. We're not talking about the east-west line. So this is a little different from our usual problems because we usually talk about the degree between the x-axis and the angle. For bearings, we talk about the y-axis and the angle. So it messes everything up and it confuses you. So again, bearings, we talk about the north-south line. Everything else, we talk about the x-axis, but bearings is weird. Hopefully this helped. If it didn't, oh well. Hopefully you're having a great time without me. Have a great day.